Welcome in to the ProtoPod, the show where we talk to innovators, engineers, and entrepreneurs who are shaping the future of technology and manufacturing. Today on the ProtoPod, we're joined by Jason Sicotte, Vice President of Global Product and Engineering for AMFT. Jason has spent more than 3 decades driving innovation in material science, spring technology, and product design across automotive, aerospace, and industry. We'll talk about how AMFT is engineering resilience into their supply chain, what global yet local manufacturing looks like in practice, and how design thinking applies just as much to operations as it does to components. Welcome in, Jason. Jason, welcome on the ProtoPod, VP of Product and Engineering at AMFT. Super excited to have you on and to learn more about not only yourself, AMFT, but also what you guys bring to the manufacturing space and what you think are key values that you guys hold, because I've read up on your bio and it seems pretty interesting.
Awesome. Yeah, thanks, Jordan. Very happy to be here. Yeah, let me talk a little bit about AMFT, and I think it's kind of instructive if we start talking about how Associated Spring started, because it actually mimics exactly how AMFT is growing. So Associated Spring started back in the 1800s, late 1800s, first as Barnes Spring in 1857, and then Barnes realized that he needed to grow and service different areas with different companies, and he linked up with other companies, other spring companies, one in Pennsylvania, which we still have today, one in Detroit. Those came together under a group called Associated Spring, so they can grow and service more customers. AMFT is very much the same thing. So AMFT started with Associated Spring as the core company. Now we're adding on different companies. So we have Heinz Hanke connected to us, E. Winkman in Germany, AH Metal Stamping over in Denmark, Skodai in Chicago. So it's very much the same model of what we did, or what they did with Associated Spring back in the 1920s or before that, just to service customers in many different areas.
Interesting. So I know that obviously incredible. The business has been around in many forms, for over 100 years. I know that you've been with AMFT for quite a while. Do you want to give myself and the audience, how your career has progressed with AMFT and how you kind of got to where you are now?
Sure. I'll start with education. So I went to University of Connecticut, undergraduate, did my master's in material science. So I was mechanical engineering, material science engineering. And luckily in my hometown, Associated Spring had a brand new R&D lab they were setting up. So it was new equipment, new high-tech instruments like electron microscopes and X-ray diffractometers to measure stresses. I was like, yeah, fresh out of school, I'd love to work there. So I started there as a metallurgist in the laboratory. Fortunate to learn something from really bright guys. So I was mentored by a PhD in material science. So it was a great environment for me to learn and be exposed to all the products globally that the company produced. So from there, I grew and went more into design work, more customer-facing work as a product engineer, then eventually materials and process engineering manager, always working centrally, never tied to just one site, which is a huge benefit because I had exposure to all of our flat products, our coil products. And ultimately, if you really understand the physics of what's happening with these products, it doesn't matter what the shape is, right? If you really understand the physics of metal, material properties, it doesn't matter if it's a spring or if it's a coil spring or a flat spring or a stamping. It's just steel with certain mechanical properties.
Interesting. So you've really had a fairly wide breadth of experience at AMFT, from the R&D, direct product innovation side all the way up to management. What is it that you think AMFT does, and as from an innovation perspective, in the manufacturing space?
In the manufacturing space, from regards to innovation, we do a lot. So, and the good thing is each site has their own engineering. So each site has their own engineering team. So it's not just centrally controlled. So at each location, they do their own deep dive engineering and innovation. So each site is, I like to say we have to become trusted advisors to work with our customers. So if our customer sees us as trusted advisors, then we can really partner with them. They approach us with problems, and that's how we innovate. right? So the customer comes to us, and we'll side by side with detailed engineering analysis of what's the problem, how can we solve it, and come up with a solution. Whether it's again great stuff at E. Winkman, Heinz Hange, all sites have their own group doing this.
Interesting. So that definitely makes a lot of sense that you're kind of driving your solutions and what you're innovating on based on the feedback of your customer to solve their unique challenges. I also noted that you guys have a big emphasis on engineering supply chain resilience. Do you want to tell me about what that means? How are you innovating in that space?
Sure, it's kind of interesting. You could look at that from two different points of view, really. So you could look at it from the point of view of us as the supplier, right? Mm-hmm. So we are part of the supply chain supplying our customers. So to that end, we're looking at from, to be resilient, we need to have capability and capacity in multiple locations globally, right? Because as we learned in the past, 5 years plus between pandemic and geopolitical stuff, there's a lot of stress on the supply chain potentially. So we're taking the point of view of we'd like to have a duplicate capacity or capability in different locations, across the globe. So, for example, we have a product we make right now in Heinz Hange in Switzerland. It doesn't really make sense anymore from where the customer is taking the delivery and from a cost standpoint. So that product line is being moved completely to Singapore to be closer to our customer. So from that point of view, we have a resilient supply chain that we can supply from different locations.
Absolutely. So the redundancy factor. Is there any innovation or development in the process of manufacturing that also assists with that?
Oh, absolutely. I mean, that goes hand in hand between product innovation and process innovation. That's fundamental to our business, and the processes really are the key to our business. The way I like to describe it internally, I keep going back to a spring, or it could be a stamping like this. Mm-hmm. All of our businesses do the exact same thing at some level. Whether it's the coil spring business or the stamping business, end of the day, they buy a piece of metal, they add value to it, and sell it to a customer. Right? So what's the value we add to it? It could be stamping, it could be stamping holes in it, it could be coiling into a spring and then doing a certain heat treat process or a shopping process to make it last longer. The more value we could add to each piece of steel we buy, the better for our business. So process engineering really is critical, both to have better, more advanced processes and also lower cost, high volume processes. So it's kind of twofold, capability and also cost.
Yeah, I think that's kind of where I wanted to get to. And what I see is that for a business like yours, both innovation on the product side and on the process development side are critical. I'm curious if you have any insight as to what sort of commonalities that you've seen over your years and wide experience in both avenues. What things are common as keys to success in that innovation, whether it be product or process space?
Well, I think one key to success absolutely has to be the best quality, mm-hmm. right? So you can develop what may be a great process, but if it can't yield, a certain percentage, a certain low ppm level of defects or something, mm-hmm. it won't be commercially viable. So the one commonality I think is across all these processes, they have to be robust, right, with the best quality. Mm-hmm. So that's probably one of the key points I would say.
Absolutely. I know that one theme that comes up commonly on the show, and it sounds like it would be applicable with you and your team, is, especially when problems are difficult or novel, that one of the keys to success is when resolving those problems, absolutely the outcome must have a quality standard to it that is high to produce a good outcome. But the innovation process in itself is very closely connected or correlated to how quickly you can move through that innovation. And we like to talk about that as the velocity at which you can move it. Can you touch on that and maybe where you've seen that throughout your career, how velocity has played an impact in successful innovation, whether on the process or product side?
Yeah, absolutely. Velocity is critical, especially I think more so today. It seems like today, things move a lot faster today. It seems like maybe it's just my different perspective as I get older and advance in my career. I feel like back in the late 90s, we had more time to develop something and tinker with something and work in the laboratory and test it. Now it seems like, the pressure's not to move much faster at higher velocity. One way we do that is collaboration. So a key thing that's a real benefit to AMFT and our global approach is that if a particular site has a challenge from a customer, they don't have to work it out in a vacuum. They can approach me centrally and say, this is a challenge. We're not sure exactly how to do this. Hey, Jason, how have you done this before in a different site, right? Because we have exposure from our advanced engineering group to the different sites and different people too. So I could say, you know what? There's a guy in Brazil I know who is awesome at stamping. He had a problem like that. Let me give him a call. And now with video calls and so on, I could get somebody on video call so fast, and you can say right away and instantaneous communication in essence, and say I can support that problem. I know how to solve that. Here's what you do. So we get together on a team and then work through it much faster than we would otherwise.
I love that. Again, it ties so many themes. It's so interesting how successful companies kind of somewhat operate very similar ways. So, the idea of stealing somebody else's 10,000 hours of expertise in a field, right? So to this one group of individuals, this is a complete unknown. They have no idea how to move forward through this. And one of the themes, again, that we talk about is ruthlessly eliminating latencies and the ability to identify that unknown and know that you have to quickly move past it, be it get on a call with a guy from Brazil or what have you, is really the key to kind of making the next step and moving forward on your project and innovating. So very interesting.
Yeah, absolutely. And if you look at the tools that enable us to move fast also, I have to mention 3D printing. 3D printing has been a game changer for us. We're actually one of the first companies in our space, I would say, to do 3D printing back in 1995. In 95, we had a laminate object manufacturing machine, which did like a paper layer. And in fact, I have that part right here. I made back in 1996. It's layers of paper glued together. But you can, very quickly design something, get an actual physical piece.
So after some technical difficulties with our camera, the audience is now does not have to look at my face for the rest of the show. Jason, you were talking about 3D printing and the importance to holding project velocity high. Do you want to expand on that some more?
Yeah, absolutely. So with 3D printers, we put these in-house at each division back in, I think, 2018. We installed carbon fiber 3D printers.
Wow.
Same Mark II printer at every site globally, all connected through a network. So very cool. I could log in through the software from wherever I am globally, and I could see each printer, and I could actually hit print and print something there. Whether it's, we use it for not product. And people were mistaken thinking you could 3D print a spring. Not easy to do that because springs are really, really good and really cheap compared to 3D printing. But you can print prototypes, samples, fixtures, tooling. So we had a machine in Mexico actually manufacturing parts, and we had a design in Michigan. So we sent the design of a gripper to pick up a spring to the printer in Mexico. They took it off the printer, put it in the machine, and they're up and running. And one of my favorite examples I like to share was we had a metallurgist working for me in Michigan in the R&D lab, and she had a problem looking at a small sample that was in a beaker of acetone, and with her steel tweezer, she couldn't get the part out because it was magnetized, and it kept sticking to her tweezers. So I quickly downloaded a 3D model of tweezers. I printed it on her printer in Michigan. She took it off in 2 hours and took the part out when it was working.
Yeah, it's incredible. It's a duct tape solution to keep the project moving, and again, removing one of those latencies. It's all excellent examples. It's something that we really pride ourselves here at Protocase and Protospace, our whole family of companies, is that our whole operating mantra is that we're here to enable innovation, and we do that by helping innovators remove latency. Through our HVMC manufacturing methodology, high velocity mass custom. The whole idea there is that what we're enabling is for somebody to move forward with their project by reducing a latency dramatically. And again, it's absolutely critical, whether that be you've described it so well, the analogy of 3D printing parts. What we bring to our customers is 3D printed parts, but for sheet metal, CNC machine, the same functional difference of that quickness to remove the latency, just in different forms. Some
Okay.
3D printing as well. So it's a great illustration that you gave about why that is so important. I know that another note that I have in your bio is that you guys really take pride in building systems that can adapt and flex under stress. Do you want to expand on that? Because I think that's a really interesting thought that I'd love to learn more about.
Well, it's kind of the more the supply chain. The supply chain can flex under stress, and we look at it from that standpoint of our suppliers. I mentioned before that we look at it as we're the supplier, part of the supply chain, but also we have a supply chain that supplies us. So, it's important for us to have multiple sources that are approved and can supply different, the same material, same grade to our material specifications, but from different locations. So, again, if we're looking to transfer a product from one site to a different site, globally, we know we can find somebody else from that region that can actually produce, the same grade to our material specifications. So from that standpoint, we can kind of flex our supply chain to get parts from or raw material from different regions of the world to the same quality levels.
Okay, interesting. So, Jason, obviously you have so much experience with AMFT, and you have such a deep understanding at every level of the organization. So, Jason, is there a specific product or project that in your career that you're maybe most proud of? I know there's probably many that you're proud of, but if you could pick out one, what would it be?
Yeah, good question. There definitely is one, and we have to go back at least 20 years for this one. This is a shot peening process. So shot peening is a critical process that we do to springs to give them better fatigue life. You hit them with a small particle, and it puts in a compressed residual stress. At this time, back in like the 2000 timeframe, there was some papers published that you can get really, really good internal residual stresses with ultrafine particle media. So I'm like, that seems interesting. Let's explore it more. I read more papers about it, about the research, and I went and sourced and actually got a bag of this stuff. I was able to find this media, very small media. And I very clearly I remember one of the operators left in the R&D lab said, "You paid that much for dust. It looks like it's just dust." Well, turns out we actually, put the dust in the right machine. We did the process, and using the instruments we have the X-ray machine, X-ray diffraction, and we have an electron microscope. We quantified it, and it turns out it was fantastic. It gave us really good results, and that became the foundation of all of our racing business, all of our race valve spring business, even lots of other springs. We then do a technology transfer. So we take that technology developed for racing, and we applied it to a lot of other different markets successfully. So it's a critical one where it starts with pure R&D, reading some papers, did some in-house testing, and then now it's applied commercially to many, many different products.
Yeah, it's how one little idea and a few tests can kind of expand into this, massive scope of work, and it's really powerful. Yep. And it's again a great on that topic of innovation that we've covered, pretty extensively here. Is that a great illustration of how innovation drives growth. So I think that's a really good one to pick. In terms of what's on the horizon for AMFT, what excites you the most about where you and your team are headed and in the next 5-10 years?
Sure, that's a great one. I mean, we've only scratched the surface of exploiting our synergies of the different sites. So as we are growing as AMFT, and we have multiple acquisitions being bolted onto our company, we're looking to each one of these groups who are great on their own and taking the best practices, like I think I mentioned before, and really sharing that across the team. And as one site becomes a little more advanced, and these things happen sometimes in pockets where one engineer just takes it upon himself and says, AI is awesome. What can I do with AI? Maybe he has a great idea, but then we can capture that more fast, quickly, and apply it to different sites globally. So I think with exploiting the synergies, that's the most exciting way AMFT is going to grow in the future.
Yeah, absolutely. A callback to what we chatted about earlier, and kind of stealing everybody else's 10,000 hours, learning from each other and building on
exactly.
that. Yeah, I like that. So before we conclude, I did want to run through my rapid fire question segment with you.
Sure.
Are you ready?
Let's go.
Coffee or tea?
I'll be more specific. Iced coffee.
Iced coffee. Okay. Early bird or night owl?
Definitely night owl.
Night owl. Analog or digital?
Tough question. I mean, I hate to say it depends, but it depends. I love a manual 6-speed transmission where I'm more analog shifting myself, but I love a paddle shift transmission too. So a little bit of both.
I love it. I love it. Good answer. Data or intuition?
Again, at risk of being that guy that says a little bit of both, sometimes, and that comes with experience of having 30 plus years, you can go with your intuition and actually make the right decision quickly. Sometimes, if you're not quite sure, you need to go back and look at the data to make the best decision. So it's in between.
No, it's a good answer. It kind of depends. I think that's the right answer. It's a bit of a gray area. Office work or hands-on in the lab?
Same theme. So there's strong benefits to both. I'm very much a hands-on guy. So I guess my first go-to would be hands-on in the laboratory. It would drive me crazy if we sit around talking about what may happen if we heat treat a part to a certain temperature and we're not sure what happens. Just go do it. Just go to the lab, go do it, and hands-on and see what the result is and measure it. So I'd say hands-on.
Absolutely. Reduce that latency and resolve that unknown. I love it.
Yep.
Risk taker or perfectionist?
It depends again. It depends on the consequence of failure, right? So I talk about in some training I do, especially with springs, how robust they have to be depends on the consequence of failure. The risk taker could be, you can go more risky if the consequence of failure is low, and you can just go with it, make a decision, move on. If it's a critical thing, like we're talking about this cool part that we actually have in the James Webb Space Telescope, where failure is not an option, it's no risk allowed. So it's in between.
Absolutely. Depends on the context.
Yep.
One tool that you can't live without?
Good question. One tool I can't live without.
Is it that one that's sitting to your right?
Yeah, okay, yeah, it's a good one. The microscope. I'm glad we talked about this before. So, I started my career using a microscope to look at broken springs, to look at fractures, to look at surface quality. So to me, that's, I think, the most important single tool is for my career. I'm always looking at things, always looking at whether it's just a manufactured surface, just a shot peen surface, just an as-blanked edge maybe, or a fracture surface to understand the manufacturing process.
Absolutely. Last one, your favorite place to go for inspiration?
Favorite place for inspiration? I think I would definitely say the beach. And the reason for that is when I go to the beach and it's bright sun, right? You typically can't look at a phone. So phones are a big distraction and you're always like, your brain goes somewhere else. You don't have free time to just think. When you go to the beach, I think you're free of that. You're just laying in the sand or a sun or whatever you like. And, your brain's free to wander a little bit. I don't know if it's a curse, but for me, my brain wanders to a spring process. What can I do different? Or how can I make something better? But you're free to brainstorm more, I think, when you're not having distractions in front of you. So that's my location, the beach.
Yeah, that's a really great point. And I've read some things before about boredom and how a lot of creativity comes from boredom, and the phone to kind of distracts you from being bored, but is ultimately a detriment. So I think that's really insightful.
Yeah, I couldn't agree more. That boredom comment, I've seen a story about that online somewhere. Important to be bored sometimes, to let your brain wander and actually come up with new ideas.
Absolutely.
I agree.
Jason, I've enjoyed our conversation so much. It's been so great meeting you and learning more about yourself and AMFT. If folks listening are looking to learn more about AMFT, where would they find out more information? Yeah,
our brand new just launched website, www.amft.com.
Amazing. Well, Jason, again, it's been an absolute pleasure. Until next time, hopefully next time we have you on, you'll be able to see me for the whole time, or maybe not. Hopefully, maybe that was a benefit for you. But it's been awesome, and thank you so much.
Awesome. Thanks, Jordan. I appreciate the opportunity.
All right. Bye-bye, Jason.
Thanks. Bye.